So today we're going to talk about 2025 network trends, really starting at a high level, kind of talking about what that means from a kind of buzzword perspective, new feature bullet points you're going to see from various vendors, kind of technically what that means, and then ultimately a little bit of perspective as to how we're viewing it from the visibility and detection side and kind of determining where we fall into it and what our compatibility looks like there. So my name's Adam Howarth. I'm the data scientist here at Plixer. I work on the team that develops our machine learning detection-based algorithms, as well as working on future research projects and again, looking at topics like we're going to look at today and figuring out how we can best apply from a monitoring and audit and detection perspective our technologies into that space as they change. So from a really high level, these are the items we're going to cover today: AI-powered networks, networks as a service, hybrid and multi-cloud environments, really the propagation of those, since that's kind of already well on its way happening. Edge computing expansion, sustainable networking, and then kind of just a fun, maybe a little bit beyond 2025, but you'll start to hear it this year, quantum networking discussion. So first up, we're going to talk about AI networking. There's a few language collisions here, just to clear up before we start, where at kind of the lowest level, we have this new paradigm growing of these giant AI compute data centers starting, where you're seeing really interesting applications of new networking paradigms like RDMA, NVIDIA spine stuff, 800 gigabit per second links in order to let, 64 of these giant GPUs talk to each other at once and work in a high compute environment. That's really going to be one phase of AI networking, what it means structurally to changes that are going to happen to the data center. What we're going to really focus on are control plane decision making that will be leveraging AI. And then finally, there's kind of a language collision that'll just come up a lot where you hear things about AI routing and AI networking that actually is more along the lines of net model selection. So maybe you have a really high powered LLM that your enterprise has access to that's offsite, but you have some local ones that are a little bit smaller for specific tasks. How are those things routed around? So those are really the three components of AI networking that you'll see colliding under the same language a lot. The actual data center paradigm for it, the control plane things, you can think like intelligent SDN, which we'll get into. And then finally, application layer AI networking, which is a little bit beyond the scope of what we're looking at today. But again, those are just language collisions. So it's always kind of imperative to figure out which, one you're talking about. So focusing on the control plane, really AI is always going to be a good application anytime you have really repetitive tasks or kind of the idea of like who's actually going to go through and label all these things or do all these things or review all this data. Any workflow that involves that kind of one to N application where one agent, whether it's a person or as we're going to see as we move forward, AI agents have many tasks to complete that are kind of unbound. We'll talk through a couple of those things in a moment, but ultimately that will take down any task that just eats up time, and really that time requirement blocks you from getting optimal results. Once that's automated and an algorithm can just go through and do that, suddenly that time constraint goes away and you can actually take advantage of some of these more specific features of a networking paradigm. So going through some of those items, one place we'll see this is IPv6 has the ability to have per packet level segment routing. So you can put control plane instructions directly onto an IPv6 packet. This has always been an IPv6, but it becomes one of those cases where it's a very verbose problem to solve. It's a lot of labeling and it's a lot of kind of manual maintenance to do to keep it up, which has been prohibitive to its adoption. As soon as an AI-based agent can do, QoS optimization, better traffic classification, a few things we'll talk about down this list, all of a sudden it becomes possible to actually leverage that feature and move those control plane decisions to a per packet state and allow for much more intricate and detailed long-term routing planning to keep your control plane, running optimally for how the state of the network is at any given moment. One example of that is going to be better traffic classification at high traffic volumes. So right now, kind of the state of the art for traffic classification is deterministic based on looking at payloads of data. But what ends up happening at higher volumes is the amount of time you have to process those packets shrinks and shrinks and shrinks to a point where you can't actually complete the full payload analysis in the delta of time you have before a new packet arrives in that same queue to work on. Ultimately, what that means is that classification on a flow-based level, kind of the world we live in here at Plixer with IPFix records, those models are getting better and better all the time, where we can use unsupervised models and supervised models, cases where we know what the traffic is and what we don't know what the traffic is. And the kind of development that makes this a future looking concept in AI networks is bridging those two worlds. So once you have some way of classifying data in a supervised manner, classifications that are made in an unsupervised manner can take in other forms of data, label those unsupervised clusters, and then integrate them into your supervised world. What that ultimately means is much higher fidelity traffic classification and a resistance against kind of this scale problem that we're going to run into as things get faster and faster. As I mentioned at the top, if you think about the paradigm of AI data centers, those are running at 800 gigabit per second at their aggregation points. So the time delta, you start to talk nanoseconds on a per packet processing basis. So it really requires abstracting these classification things to higher level metadata, where you can look at a lot more data at one go. So having kind of a smarter controller to join those classification routines ultimately will lead to much higher detail in what those classifications are. Anyone that's run kind of NBAR based labeling or a lot of the lighter DPI solutions will kind of know that sometimes they're overly general and traffic will be kind of misclassified based on some rudimentary things like the port that was used or something. This enables us to move further and be able to more granularly identify subclasses within the classes the larger class, the old technology would have seen. And then again, ultimately that feeds into this higher level paradigm of smarter decision making in the control plane. Another point that I've talked to vendors quite a few years ago that were working in this space, and they had found success in port channel optimization. Really, what it comes down to is whether you're doing like per destination or per packet based load balancing. Right now, those are things that are kind of manually configured on a per application basis. Again, bringing AI into the control plane is going to allow for that load balancing to be done in a smart way that isn't stuck against one kind of deterministic algorithm. It can learn how that port channel or whatever is used over time and continually optimize it in order to keep things moving quickly. That's an area that I know vendors have, hardware networking vendors have found great success in early on in kind of the ML revolution. And now we're a few years into that. So at this point, this is probably less of a upcoming trend and something that's hitting products now. And then finally, this whole paradigm really consists of the idea that this is a state-based control plane decision-making paradigm. So if you think like probabilistics versus Bayesian, if our traditional routing states are kind of, we preset everything up and get link states propagated everywhere so things know where to go. This is moving more to a paradigm of you start from that phase, but then observe the actual state of the network, how it's being used, and then make a state-based update to keep things optimal for exactly how it's being used at that time. So it's really a major shift in that sense of kind of moving from a prior understanding of how the network would be used to a posterior understanding of how it's actually being used, and then optimizing against those things. So from our perspective of monitoring, there's a pretty famous paper that goes back to the early days of IBM Watson, when it was like on Jeopardy answering questions and stuff, where IBM discussed the idea of needing to actually audit and manage the decision chain once an AI is making kind of these process-based decisions. So that way you can actually go back and review what it did and have some idea, of what actually changed. So when problems arise in that new world where you have kind of this really smart control plane, you actually have some way of troubleshooting and going back through it. IPFix is a great solution for that, just because everything that happened on the network, including where it happened on the network, what interface served that, what queue it went through, can be reported in IPFix, and it gives us a way to go back and look through it. And that's going to be more important than ever as we get more removed from actually defining the rules that set up how things are routed around the network. On to the next topic, network as a service. This is kind of an exciting one. You'll see lots of vendors. I think probably suddenly social media and everything seems to know that we all work in this industry. So you'll see ads for it all the time. This is definitely a space that seems to be exploding right at the moment. It's really not a huge new idea. It's kind of in line with everything that's been happening as we've moved workloads to the cloud. The difference here just being is moving major components of kind of a WAN network off-prem and not needing the equipment on hand yourself. So deployment moves from a ordering equipment, installing equipment, and getting it set up to just going online and using some sort of API to stand it up. Right off the top, you can see how that cuts a ton of time out as far as personnel that are required for these updates and things like that. But it also takes the bound off integrating more deeply into a cloud-based or hybrid-based environment where it becomes a similar process to setting up compute out in the wild, setting up kind of a network backbone to bridge those cloud services. So network scaling, faster deployment, latest technology access, you're no longer bound to refreshing the hardware yourself. So on the previous topic, you talk about AI power control planes. Maybe that's not something that's in the technology you have now, but now you can just kind of go out and rent a network that's already been provisioned that uses technology that maybe it would be pretty laborious to get involved in your network otherwise. Really, agility, speed, and not a need for personnel to make those changes is going to be the biggest winning component of network as a service. Again, from the monitoring perspective where we live, again, it's going to be more important than ever that these services can actually export records of how things were routed around for you for compliance reasons, auditing reasons, security processing reasons, whatever, all the way down through performance reasons, right? All of a sudden, if you have no visibility into links on your network because it's being provisioned by a network as a service vendor and you're having some sort of network performance problem, you're going to need metrics to analyze to figure out what exactly is going on there, escalate that problem up as it goes. So doesn't really change visibility at all. We'll still have the same needs to see kind of what's being sent where, but it does change the kind of who's housing the hardware and moves it up to kind of a shared environment, really a paradigm we've already gotten used to with compute as far as using AWS, et cetera, goes. On that point, we're going to see more growth of hybrid and multi-cloud networks. I think at this point, for years, this was a thing where we were talking about like, oh, it's coming, and maybe the enterprise had one or two services that they had pushed out to a cloud service. But nowadays we see almost everything's moving that way. When you start looking at new products and new tools and solutions in your space, a lot of them are going to be SaaS-based offerings that'll move out to the edge. In the case of networking, again, along the lines of the network as a service thing, we are still servicing devices that are local. So there's always that small component that will be kind of your tangible network that you need to service. So that really just falls further into this paradigm, right? So instead of just our compute loads up, now we have actually some network capacity that's been offloaded. And we further just need to kind of understand how that integrates back locally into our environment. And again, along the kind of audit and compliance needs. So again, same as NAS, more flexibility, it's easier to integrate across platforms because you kind of have this tertiary layer in between. Cost and performance optimization is just going to move out because you can kind of run jobs wherever it makes the most sense from an economic perspective. And then ultimately visibility challenges, where can you get visibility from, since the compute's going to move around, the traffic's going to move around, the hosts that are being serviced are moving around. So again, all of the cloud vendors can kick out IPFix, and obviously all of your local devices that are kind of servicing the connection up are going to be able to kick out those observations. So we'll still, from a Plixer platform view, be able to keep all these observations in one place. It's just kind of more important than ever to have a central aggregation of those things, because the source of that data is going to start to move around more and more as we move our workloads up and out of our kind of on-prem situation. To that point, edge computing is developing further as people figure out what makes sense to keep local. Primarily, this is like a latency and performance consideration. There are some applications, those extra hops to get out to the edge are just kind of unnecessary and ruin the user experience. All the way back through considering, cost. A lot of times egress is very expensive from cloud-based networks. So, what devices does it make sense to keep local to minimize kind of those exogenous costs that pop up as you move into that paradigm? So edge computing, in our example, you can think of like we have network probes, the FlowProbe product. That's going to look at raw traffic in a local sense. But if you are running in a cloud-based situation, you'd actually want to send that data up into the cloud for aggregation and processing. And then you can kind of think of that across the board. IoT devices, anything that's running in like a manufacturing setting, may need to go up and talk to the edge, but any sort of real-time sensitivity can be exposed through latency that's introduced by moving across VPN tunnels and then jumping around a bunch of data centers. So over time, I think we'll refine down to exactly what devices need to stay local in order to keep performance up, and then ultimately kind of bridging all of the visibility from a security, audit, and compliance perspective is going to remain kind of at the forefront of what we're considering. Sustainable networking. This is kind of a really interesting one. I know over the past few years, like everything's kind of gone green, become efficient, and work better. But what's beginning to happen is photonics are making great leaps. Really the idea of computing on photons instead of electrons. Right now, a lot of those tools kind of sit right in, like an SPF, like an actual optic network interface. Photons come in over the fiber, and it has some immediate hardware for processing that and then turning it into an electronic signal. What you'll see over time is that we'll move deeper and deeper into the core of networking equipment. I don't know if this is going to be a this year thing or not, but it certainly will start to come up as a buzzword quite a lot as they prepare to integrate this into products. But ultimately, those devices run a lot cooler and require a lot less energy to run. I know I've seen it already in the machine learning space where people are starting to look at taking the weights of neural network and basically burning them into a structure where a photon can just refract around that structure to do the matrix multiplication that otherwise would have to be done in quite a lot of operations in an electronic context. So that's really going to be the major component here. It's kind of to be determined what the infrastructural signals we'll want to measure and keep track of from a monitoring perspective. But ultimately, this will be something that will slowly creep into that space for the items that do remain on-prem. If we think back to the hybrid environment, over time, the operation of those devices is going to get a lot more efficient. Really, as speeds go up, that's going to be necessary. Because again, going back to kind of these really high throughput RDMA-based data center designs, those devices, when we start to run them in aggregate with a lot of them, need to take their kind of energy consumption down in order to not, prevent a scaling problem. And then finally, just kind of a fun one to talk about. This is really going to be a buzzword that I think is going to be misused quite a lot and used to like sell things. But quantum technology is, as of a few days ago, Google's figured out how to solve some of the major error correction problems they had in quantum algorithms by basically structuring everything in like this interesting lattice design that prevents, instability problems that otherwise they were running into in quantum. So that opens up a few different things. And again, there's a few language collisions that will happen when we talk about quantum networking. Really, the two paradigms there are going to be the actual networking of the entanglement states between quantum systems. Right now, this is just a really kind of niche high compute problem, but I think pretty quickly, once they solve this, it'll move down into an enterprise utility just because the problem set it can solve is kind of huge and not something that we can approach with binary compute currently. So on one side, there's quantum networking in that sense. How do we network quantum devices together without needing some sort of binary intermedium in between? And then secondary, what we're going to talk about more is something along the lines of quantum key distribution, where as things like Shor's algorithm, and I think Grover's algorithm is really the one that's a threat to SHA and other, kind of traditional hashing techniques that we have. As those develop more and more, our current state of cryptography may begin to have lots of holes in it and vulnerabilities in it. For a little while, we'll be able to put that off by just moving up in complexity, like SHA-512 will be, twice as difficult for them to kind of brute force through as SHA-256, because right now the idea would be you can apply a quantum algorithm and basically have the bit complexity of those things. So SHA-256 with Grover algorithm applied, it turns it into like a SHA-128 complexity problem, and basically just shrinking the space you have to brute force to figure out what the initial input was. So that's really the main concern there, is that as quantum technology it improves, really any kind of black box algorithm like a hashing scheme where some input goes into a black box and produces some output, there will be a set of algorithms that can solve and reverse those inputs, breaking those things. So quantum key distribution is going to be the idea of we now need to secure things with the same complexity, and there's algorithms that are being developed for, encoding those things, as well as the actual physical distribution of entangled quantum bits. So again, this is quite a ways off, but I think it's close enough where people will start to throw quantum on everything, like AI was being thrown on everything in like 2016, even though the tech hadn't really caught up to a point where it was deployable yet. So a very exciting space for sure. But it is important to keep in mind that there's a few topics there. There's really the security side of cryptography and how that can be broken and how it needs to be reinforced, as well as the very real problem of in research settings, especially for the near future, how you actually network together quantum systems and what does visibility on that look like. So this is really some edge stuff that we haven't really started to consider yet, but we can see on the horizon is coming. Is what do people want to know about networks that are doing that? What's important? How do you audit it? And what again, it's a whole new paradigm. So what does it even mean to do knock and sock operations against a completely new type of network altogether? Because it's probably the protocols we're used to aren't even going to exist on those things. So this could be a real fundamental shift, and kind of just understanding how to do it safely is going to be kind of the principal component there. So that was just kind of a quick run through of those things. If you're an existing customer of Scrutinizer, reach out to support, and we can always talk about if you're getting new technology, changing around kind of your deployment scheme, moving things into the cloud that had been on-prem traditionally. We have a great support team that's constantly working with people to kind of redefine where they should be getting visibility from to keep their solution complete from that sense. If you're not a customer yet and you're interested, you can talk to our SE team and they can look at kind of what your plans are for the network, what it currently looks like, and how maybe we can be a good fit for visibility and detection in that scope. But otherwise, please follow us on LinkedIn, reach out. We do content pretty regularly and would love to kind of have a discourse back and forth with everybody. But otherwise, thank you for joining today and happy holidays.